Subtopic 8.3 Thermodynamics. In this video, we focus on these two learning outcomes. Alright, the first one is to state the first law of thermodynamics. Q equals to delta U plus W. The second one is to solve problem related to the first law of thermodynamics. Introduction. Alright, so thermodynamics is actually the study of how energy can be transferred between gas system and its surrounding. So we actually focus on energy transfer, whether into the gas or out of the gas. So effect of this such energy transfer will change the amount of internal energy of the system. What is internal energy of the system? It is actually the energy of particle in the system, where in the gas we have a particle, where this particle has kinetic energy and potential energy. For ideal gas, this particle only has kinetic energy. Okay, so when the internal energy increases, that means the kinetic energy of the particle also increases in the gas. If the internal energy decreases, that means the kinetic energy of the particle in the gas also decreases. Next, this will affect the microscopic properties of the system like pressure, volume, and temperature. Alright, now let us have a look on the definition of first law of thermodynamics. It states that the heat supply to a system is equal to the increase in internal energy of the system plus the work done by the system on its surrounding. So in terms of formula, it is Q equals to delta U plus W. When we want to write the definition in terms of formula, we have to write the definition for each term, where Q is quantity of heat supply, delta U is the change in internal energy, and W is the work done. Now, let's have a look on the diagram on the right side. Okay, so here is heat supply. We heat up this gas, that means we heat supply into the system. Alright, what happened to the particle inside the gas when it is heating up? It gains energy, right? So that's why heat supply equal to the increase of internal energy of the system plus the work done by the system. Why by the system? Because this piston will move upward. That means the volume of the gas increases. When the volume increases, the work done is by the system. Alright, that is the definition for the first law of thermodynamics. And this law obeys conservation of energy. Now, let's have a look on the Sine Convention. This one is really important. Okay, so you have to be careful. For Q, the positive sign convention is when the heat absorbed or flow into the system, positive. But we use negative when the heat lost. Or we can also say the heat flow out of the system. Okay, that means the system is cooling down. Alright, delta U, when the internal energy increases, that means increase of temperature in the system, we use positive sign convention. But when U or internal energy of the system decreases, that means the temperature decreases, we use negative sign convention. Last one, work. If the work done by the system, then we use positive sign convention, and work done on the system, we use negative sign convention. So next, let's have a look on in detail about work done on and work done by. For work done on the gas or on the system, the volume of the gas, as you can see here, the volume of the gas decreases. When the volume decreases, the work done is on the system or on the gas. Meanwhile, the work done by the system is when the gas expands. Okay, that means the volume of the gas increases. Alright, so we can say that if the volume does not change, therefore the work done becomes 0. So please take note this one. Now let's have a look on example 1. In each of the following situations, find the change in internal energy of the system. So we have to find delta U. Right, the first question, system absorbs 2090 joule of heat and at the same time does 400 joule of work. Okay, so absorb, we use a positive for heat, and work done, the system do work. That means the system do work means work done by the system, positive 400. Then we substitute values into the formula or equation. Then we get internal energy positive 1.690 kilojoule. Alright, question B. A system absorbs 1255 joule of heat and at the same time 420 joule of work is done on it. So heat positive because system absorb. So work done is negative because the work done is done on the system. Okay, so we use first law of thermodynamic equation. We substitute all the values with correct sign convention. Then we get a change of internal energy 1.675 kilojoule. Alright, C, 5020 joule is removed from a gas held at a constant volume. Given your answer in kilojoules. Alright, so Q or heat is negative because the energy removed, and the work done is 0 because there's no change in volume. Okay, so we substitute for Q, work is 0, then we get delta U or change in internal energy equals to negative 5.020 kilojoule. Okay, that's all.